previous slide at our list, we've got to figure out what can I divide 120 by. So you want to check, starting from the bottom and work your way up. What can you divide 120 by? So go ahead and take a look at your list and see if you can figure that out. Okay, and as you go through your list, we can only break 120 down into 4 and 30. So we end up with the square root of 4 over the square root of 30, and that turns out to be 2 square roots of 30 over 5. Now the last thing I would want to check is, can I reduce my plain numbers? Can I reduce the 2 with the 5? And for this one we can't, so our final answer would have been 2 square roots of 30 over 5. Okay, this third example is a little bit different. Think of this problem as they broke it down like we did right here, but they did a bad job of breaking it down. They didn't break it down into anything that was perfect. So what we need to do is we need to go and we need to put them back together and then re-break them down. So when I have the square root of 2 and the square root of 10, I'm going to rewrite that as the square root of 20, because 2 times 10 is 20. Then I'm going to break it down using the perfect squares. So on your list of perfect squares, hopefully you notice that it breaks down into the square root of 4 and the square root of 5. Well, the square root of 4 is 2, so we end up with 2 square roots of 5. Okay, here are 3 more practice problems. Go ahead and pause it and see what you come up with for each of these. First one, 18 breaks down into the square root of 9 and the square root of 2. Our square root of 9 is 3, so we end up with 3 square roots of 2. The second one, I did a little differently than what you might have. This 12 here, I noticed would break down into 4 and 3. So I went ahead and I broke that down first. So I changed it into the square root of 4 times the square root of 3, which gives me 2 square roots of 3. Then, the only thing causing the problem is the square root of 3. So I get to multiply by the square root of 3 over the square root of 3. And all that does for me is it's going to give me smaller numbers. Instead of multiplying by the square root of 12 over the square root of 12, my numbers are going to stay a little bit smaller because I simplified first. If you didn't notice that, you'll just have to simplify at the end. So when I multiplied these out, I got the square root of 33 over 2 square roots of 9. Well, the square root of 9 is actually 3, so I end up with the square root of 33 over 6, because 2 times 3 gives me a 6. Now this last one I left alone because I didn't know for sure how well you'd do with it. First thing I want to look at, my plain numbers. I can go ahead and multiply those together like a regular multiplication problem. So 6 times 3 is 18. Now this 20, I'm going to break it down first into the square root of 4 and the square root of 5, because I want to use a little bit smaller numbers. Well, I know that the square root of 4 is 2, so I'm going to have 2 square roots of 5. What that means I can do now is I have 18 times 2 square roots of 5 times the square root of 5. Well, 18 times 2, I can multiply those together because they're both regular numbers, so I have 36. And the square root of 5 times the square root of 5 is 25. And then our square root of 25 is actually just 5. So we end up with 36 times 5, which ends up being 180. So this one, if you were to go through and type in your calculator 3 times the square root of 20 times 6 times the square root of 5, hopefully it turns out to be 180. Okay, now we are going to look at how we can solve quadratics using radicals and square roots. Now you have to keep in mind that you have to rationalize your answers and simplify any of your answers, so we are not allowed to have decimals here. We can do this using algebra when the variable is only in one place. It makes our solving quadratics much easier, because up to this point we would have had to factor it out. So I look at this problem and I notice that I have x only in one spot. Immediately I should think I can do algebra. I still need to follow my order of operations, so I subtract 3 off first, and I have 2x squared is equal to 40. Then I'm going to divide by 2 just like you would when you're solving a regular problem, and I end up with x squared is equal to 20. Now I have to realize to get rid of squared, I need to square root both sides. So I'm going to square root both sides, and the square root and the square cancel each other out, so I'm left with x equals. Now since I applied the square root, you have to remember to do the plus minus. So this would be plus or minus the square root of 20. Before you call it done, you want to check, can you reduce it? Can you simplify it? Well, the square root of 20 breaks down into the square root of 4 and the square root of 5. Square root of 4 is 2, so I actually have x equals plus or minus 2 square roots of 5. Now to check this, you can use your calculator. You can plug in the 2 square roots of 5 in for your x squared and follow this formula, and hopefully it turns out to be 43. Okay, our second example for solving quadratics. This one's got a little bit more stuff with it, but we still follow our same rules. X is only in one spot. So I'm going to go ahead and get x by itself. I add 12 to both sides. So I'm left with 1/3 times x plus 5 squared is equal to 21. Then to get rid of the 1/3, I multiply both sides by 3/1. Those cancel out to be a 1, so I'm left with x plus 5 squared, and 21 times 3 is 63. Now I can't get inside these parentheses to get rid of that 5 until I get rid of the parentheses, and I can't get rid of the parentheses until I get rid of the squared. So I square root both sides in order to get rid of the squared. So I'm left with x plus 5 is equal to plus or minus the square root of 63. Don't forget about that plus minus. It's an easy detail to miss. Okay, I still don't have x quite by itself, so I need to subtract 5 from both sides. And I'm going to put this minus 5 in front of my plus minus. So I'm going to end up with x equals negative 5 plus or minus the square root of 63. Now before you can say you're done, you've got to check that 63 and see if you can divide it by anything, by a perfect square. And it does break down into the square root of 9 and the square root of 7. So we actually end up with x equals negative 5 plus or minus 3 square roots of 7. Okay, see what you come up with for both of these. So try to solve these quadratics and then check with the answers I get. So go ahead and pause the video now and see if you can solve them on your own. Okay, if we look at the first one, I started off by subtracting 13 from each side. Then I divided by 4. And then to get rid of the square, I had to square root both sides. So I ended up with x equals plus or minus the square root of 75 over 4. Well, now I can't have that square root in the denominator, so I had to break it apart into its pieces. So I wrote it as the square root of 75 over the square root of 4. And then it was nice because the square root of 4 is just 2. So I ended up with x equals plus or minus the square root of 75 over 2. But then I had to check on this 75, and I noticed that it could break down into square root of 25 and the square root of 3. Well, the square root of 25 is 5. So my final simplified answer is plus or minus 5 square roots of 3 over 2. Now on the second example, follow your same process. Subtract 4 from each side, divide by a half, and then I can't get to that 8 until the parentheses are gone, but I can't get rid of the parentheses until the square is gone. So I square root both sides, and so the square root and my square cancel out. Then I'm left with x minus 8 equals plus or minus the square root of 36. Add 8 to both sides, and I get x equals 8 plus or minus the square root of 36. Now the square root of 36 is perfect, so that's actually just a 6. So I end up with x equals 8 plus or minus 6. Now since those are both plain numbers, I can actually perform the operations. So I'm going to do x plus 8. That gives me a 14. Then I'm going to do 8 minus 6. That gives me the 2. So my answers for the second one are 14 and 2. Okay, see if you can do these two problems and bring them to class.